Welcome to another Directions Mag Geospatial webinar. Today sponsored by our friends at GIS. I am Barbara Duke, Managing Editor here at Directions Magazine with our assistant webinar producer, Lynette Qualia. Thank you for stopping by directionsmag.com. For more than 20 years, we encourage you to read feature articles, daily news, listen to podcasts, and attend more webinars, of course. We are welcoming back our friends from Vertiges. Matt and Adam are here to show us how we can use GIS to improve citizen services. They have got some great examples for you and talking through how you can make that work in your organization. So, Matt, over to you to start our discussion today. Welcome.
Awesome. Thank you, Barbary, and thank you, everyone. Good morning. Thanks for attending today. I'm Matt Valiant. I'm an account manager here with Vertiges, and really excited to talk to you guys today about leading with GIS for better citizen services, and in particular, Adam at the City of Kamloops is a great example to share with us of how they've been able to do this exact thing. So really excited to get into that. Before we do, just a couple slides from myself here, and then we'll get right into the demo. So for folks who aren't familiar with Vertiges, North America, we're the developers of Geocortex software, and Geocortex software offers a collection of tools, web and mobile frameworks, and solutions that extend Esri's ArcGIS platform. You can see there we are an Esri Platinum partner, so that's less than 1% of their partner network globally, along with our specialties down there below. So we really are about extending Esri. We're very tightly integrated with the ArcGIS platform and helping you get more out of that technology. So we do have a collection of different tools like I talked about, and some of the common challenges that we help our customers address from the Esri side of things. So custom widget development is time consuming and costly, and also can get you locked into versions of technology, right? So it can be difficult. Sophisticated web app development often requires custom development via SDKs. Mobile field apps, you know, if they do what you need out of the box, they're great, but sometimes there's not a ton of extensibility there. Reporting is another big one, so bringing together spatial and non-spatial data and reports. Analytics, so being able to see who's using your tools, what services are running, performance, that kind of stuff. So there's a lot more, there's a lot of nuance within these, but those are some of the common challenges we see as customers coming to us to address. And when I think about sort of where we fit within what we call a spectrum of application delivery, so here you've got, you know, your out-of-the-box apps on the left. So I think of like Survey, 123 Collector, very plug and play, ready to go out of the box. Then you move into more configurable apps. So this is where I would say you have our viewers like Geocortex Web, Geocortex HTML, Viewer for HTML5, Web App Builder, Experience Builder. And then there's this gap here where you want to do something more sophisticated. Maybe you've gone to the limits of what's available out of the box in our viewer or in the Web App Builder environment with their widgets, and you're looking at something more sophisticated. It's typically this custom development gap, and really what we try to do is shrink that. And I think this is a great example of shrink the time needed to do that. And I think today's a perfect example because our workflow technology, which Adam's going to highlight, is really what allows us to shrink this down and be able to build sophisticated solutions 3, 4, 5, sometimes 10 times as fast with workflow versus doing custom development. So really excited for what Adam has to show you today. And then last slide for me, really just a bit about why customers choose us and like our technology. And I think, you know, ultimately it's about us making them more productive and allowing them to drive business outcomes with their GIS. So that's done in a few ways, right? Compatibility with our ArcGIS technology is obviously one of those. So the release ready specialist, when new technology is out, we're compatible, right? Development time, I touched on how much quicker you can build tools with workflow. So that's, you know, again, it's about making them more productive. And as you'll see, workflow guides users through things. So it makes what would otherwise be pretty complex tasks for folks very simple, especially if you're delivering apps for folks that aren't necessarily GIS savvy users like we're going to see today. So just a few reasons why our customers choose us. A nice quote there from one of our customers in Ontario, on the eastern side of Canada there. But yeah, that's about it for me. I want to get into the meat of things.
Thanks. Thank you for your interest in what we're doing to support municipal operations using GIS. Well, this presentation describes an initiative in the City of Kamloops Street Department. I think what we've done can be applied to other areas and organizations who have a similar need to track field operations. So in this presentation, I'll provide you some background on this initiative. I'll cover what the requirements were, the technical and process solutions we came up with, and I'll show you the user experience and the results we've realized. First, as a bit of background, streets department activities generally follow a seasonal calendar. In the winter, at least here in Kamloops, we're located in the BC interior Rocky Mountains. The majority of street maintenance activities relate to snow clearing. In the spring, we transition to picking up the sand that was put down in the winter by sweeping all the streets, repainting worn off pavement paint and repairing potholes. And then in the summer and fall, we do gravel road grading and dust control, what we call rough cut mowing alongside those gravel roads, and of course the never-ending pothole fixing. So these activities have a high demand for information. Equipment operators need to know where to go and what to do. Crew leaders need to know the status of operations at all times. And supervisors need to know more general information related to overall operational performance. So in the pre-automated environment, for equipment operators to know what needed to be done, that information was provided on paper maps. At the start of each shift, operators would take 8.5 by 11 black and white maps for an area of the city into the field to know where they needed to work. At the end of the shift, when back in the office, they'd highlight on those maps using colored markers the streets they'd worked on, which they'd then pass on to the next equipment operator for that area, so they'd know what still needed to be done. Believe it or not, the operation of tens of millions of dollars worth of heavy equipment and 38 equipment operators was tracked using paper maps and colored markers. So, as you can imagine, there are a number of problems that come with using paper maps to support in-field activities, and I've listed some of them here. Paper maps also provide a very poor archive or history of what was done. It's just not realistically possible for supervisors to review and analyze past operational data when it's in stacks and stacks of paper maps. So that was the environment, and it became apparent pretty quickly that crews needed to have access to digital information in the field to indicate what they needed to do. This wasn't a matter of just making some incremental improvements to their existing processes. We needed the ability for operators to be able to record their activities during their shift, not just at the end of it. In-field, periodic recording of what's been done would give crew leaders a fleet-wide view of the status of ongoing operations, something that was sorely missing in the paper map environment. There also needed to be an archive of what had been done to support historical inquiry by supervisors. And as most street operations happen anytime during a 24-hour period, the solution needed to be up to the degree possible at all times. It needed to be mobile, easy to use, as this was primarily going to be used by non-technical users. And as the initial project was a pilot only, it needed to be inexpensive in case we didn't go ahead with it after the pilot. So from a technology perspective, with this being a highly location-based problem, a location-based or GIS solution seemed like a perfect fit. We used Esri's ArcGIS web app builder for both mobile and in-office configurable web apps. We used Geocortex workflow to add easy-to-use custom functionality to those web app builder-based apps. We used ArcGIS operations dashboard to show supervisors views of both active and archived data. We chose iPads for our mobile solution due to their relative ease of use and low cost. And it took one GIS technician about 2 months to build the initial snow clearing apps and custom capabilities, which I'm going to show you. So let me give you an overview of how the data moves through the system. The solution we came up with was a set of apps for equipment operators, allowing them to easily tag or identify streets or sidewalks to indicate what they just cleared. We asked them every hour or so to stop what they were doing, get out, stretch, walk around their vehicle to check for any damaged equipment or maintenance items, and then to indicate on the map what they'd just done. We used the idea of these breaks to not only encourage operators to update the map, but also to encourage them to take periodic breaks for safety reasons. All operators use the same map, so it shows them where other operators are working, which helps them to work in a more coordinated manner. So when it comes, where this comes in is especially apparent because Kamloops is located in a valley with 2,000 feet of elevation change within the city. So when it's not that cold, it can be snowing at higher elevations, but raining in the valley bottom. So when that happens, predefined snow clearing zones go out the window, and instead, all operators head up to the higher elevations and start clearing where it's most needed. But now that they can pan the map around, they use that to know where other operators are working, so they can choose an area where no one is working, so they don't end up crossing paths with other operators. It seems quite simple to be able to pan a map, but when the map shows where other operators are working, it's very useful to them. So this same map is seen by crew leaders, so they now don't have to be in the field monitoring their crew's activities so much to know what's going on. And I'll show you some examples of this in a minute. And the information is also summarized in a series of dashboards for supervisors, so they can see citywide the progress of current operations and can also review previously archived events. Supervisors can pass information back to crew leaders, and crew leaders do the same with their operators. Moving on to spring activities for a minute, we use an external contractor to paint road center lines, and we gave them one of our apps so they know both what needed to be done and to record what they'd just done. The paint contractor loved the app we gave them as it clearly indicated what they needed to do. Streets crew leaders simply monitored their progress using the map. And where appropriate, we also make this operational information available to the public, so they're also aware of where our crews are working. Now, I'm going to show you a few screenshots from the apps, in this case for winter operations. Just so you know, I'm showing screenshots as opposed to a live demo, as this is operational data. So if we're not currently plowing snow or sweeping streets or painting lines, the map isn't that interesting. So the screenshots I'm going to be showing are from different types of events throughout a full yearly cycle. This map shows our street snow clearing interface. This is used by snowplow operators to update the status of the streets they just cleared. There's an icon for each type of maintenance activity, which displays an associated dialog and map layer. The icons and dialog are the Geocortex workflow components that we've added to the web app builder apps. In this case, each color on the dialog represents a different work shift. The operator chooses their shift and then selects the streets on the map by tapping them on the screen to indicate the ones they've just cleared. The next icon and associated dialog and map allows operators to know where they can apply calcium chloride, which is basically liquid salt that prevents icing. It shows in red where it's allowed to be applied, and in green where operators have indicated that it has just been applied. This dialog and map is used for identifying the streets where snow is to be picked up and trucked away, and which locations where this has already been done. They do this a couple of times a year when the windrows of snow along the edges of the streets gets too high. That happens mostly in our downtown core. This dialog and map is used to track bus stop snow clearing. That's done by our parks crews using hand shovels. The bus stops to clear are shown in red, and once indicated that they've been cleared, they're displayed in green, and you can see a few of those that have been cleared on the map. Tracking of snow clearing at this level makes sure that no bus stops are missed, and a record of each time they're cleared is retained. That's really useful for year-end reporting and for addressing slip and fall liability claims. This dialog is used by crew leaders after a snow cleanup event has completed. It archives the data and resets it so it's ready for recording cleanup operations for the next snowfall. And this is a snow clearing dashboard used by supervisors. It shows the overall status of the cleanup event with the streets that have yet to be cleared colored black on the map. At the top left corner, the total length and % complete of remaining streets to be cleared is shown. There's also a breakdown by street classification, arterials, collectors, and local roads, which helps to see if time to clear are being met. At the lower right-hand corner, there are time counters per street classification since cleanup began. Along the bottom are a number of tabs which show either the live or archived view of data for street, sidewalk, and bus stop snow clearing, calcium chloride application, and snow pickup. Here's the street snow clearing dashboard for previously archived snowfall events that's used by supervisors. The bars along the bottom represent each day that snow was cleared. The bar colors represent each work shift, and the height of the bars indicate the lengths of streets cleared on that day. A supervisor can select one or more bars, which then highlights the associated streets on the map, or they can select a street on the map and see all the records associated with that street, showing the dates and times when it was cleared. Now, that's really useful for responding to public inquiries. So, for example, in the winter, we get complaints from members of the public that their street hasn't been cleared. And using this dashboard, supervisors can easily report to the caller the dates and times that clearing of their street was recorded. It's very effective, especially when compared to previously trying to do that from stacks of paper maps. Once winter's over, we move on to spring cleanup. This app shows all the locations where we sweep sidewalks, with the ones that have been swept so far shown in green. This interface shows a dialog and associated map of all the bridges, retaining walls, no post guardrails, and medians that have to be swept or pressure washed. The ones in green on the map are the ones that have been cleaned so far. This interface shows the street sweeping data and associated dialog. Map colors indicate which streets that are to be swept soon, the ones that have had their primary sweep, the ones that have had their second and final sweep, and the ones that have been flushed and are now considered finished. We flush all streets that get pavement paint to help with the painting process. This is a public map of the same operational data showing the streets that have been swept, the ones that have not yet been swept, and the ones that will be swept soon. The intent of this map is to give a heads up to the public of when the sweepers are going to be working in their neighborhood. So ideally, they move their cars off the streets and into their driveways, making sweeping operations just that much more efficient. It also saves, in theory, many calls to our call center, answering the public's questions about when their street or neighborhood is going to be swept. But the really neat part about this is that the public is looking at the same data that the sweeper operators are updating in the field. So during this 2-month time frame, 24 hours a day, when the sweepers are running and the operators are updating the status of streets they've swept, they're also updating automatically this public map. So by taking advantage of live operational data, this public map is updated using the most efficient process possible. There is no technician type person translating operational data to the public map. And also, there's no time delay from when a street is recorded as being swept and when it appears on the public map. I think that's pretty neat. Then in the summer, crews move on to repainting pavement lines and symbols. Shown in this app in white and yellow on the map are what needs to be painted, with what's already been painted shown in green. When overlaid with the streets that have been swept and flushed, it makes it obvious for painting crews which streets they can paint next, as streets need to have been flushed before they can be painted. This is our proactive potholing app. In addition to responding to public requests to fix potholes, we proactively patrol streets, fixing any potholes that are found. Crews tag the streets that they've patrolled and fixed potholes on, and once the pothole patrolling service level for a street is reached, that's 30 days for arterial streets, 45 days for collectors, and 120 days for local roads, the status of the streets is automatically reset by the system by displaying them again in black, indicating the next set of streets that crews need to patrol and fix potholes on. So this helps to tie service levels directly to what crews need to work on a daily basis, significantly simplifying this activity for our crew leaders. And this is the associated proactive potholing dashboard, which shows in the top left-hand corner that at this point in time, 76% of arterials have been patrolled within their service level, 79% for collectors, and 89% for local roads. This helps supervisors to know how well, or I suppose how not well, they're meeting their proactive potholing service levels. We also have other summer maintenance apps for tracking gravel road grading, rough cut mowing alongside those roads, and for tracking the application of magnesium chloride, which is used for dust suppression on gravel roads. But I'll spare you more screenshots. The same concepts apply, just with different data and dialogues. So what are the results of this initiative? Well, the most significant one we noticed was much better coordination of field crews. And now that they have detailed information on what's to be done, we noticed much more consistent operations regardless of the experience or knowledge of the operator. We have about 40% turnover of operators each year, so this institutional knowledge stored within the GIS is really quite important. And all staff, from operators to supervisors, now take advantage of more timely activity updates. Another result we found was that decisions regarding operations are now being made based on current and accurate information, and that can't be overstated. And we feel that better customer service is being provided as a result of increased consistency and efficiency of operations and more current and accurate communication of activities to the public. And with in-field instructions and cautions annotated right on the maps, crews now know of those locations where they have to be extra careful. In theory, increasing safety of operations, reducing wear and tear on equipment, and stress on operators. We also discovered a number of unintentional side benefits of giving crews mobile devices that have cameras and texting capabilities. So for example, when a snowplow operator encounters a basketball hoop or a hockey net in the roadway, preventing them from properly clearing the street, they simply take a picture of it and text it and the location to our bylaws staff for follow-up. They also sometimes find tree branches weighed down by snow, making them too low for the trucks to get under, so they do the same. They text a photo and the location to our parks crews so they can remove it. Likewise, when equipment gets damaged, they text a photo of the issue to our mechanics shop, and they can determine if they have the parts they need to fix it and how big the repair is going to be, so they can then schedule equipment downtime more effectively. And from a reduction in cost perspectives, well, that's a little bit less tangible. We're still running the same amount of equipment and the same number of operators, but more efficient, consistent, and safer operations you'd think has to reduce the cost of equipment, staff, and the city's exposure to risk. So this summarizes the end of a 12-month pilot. Sorry, I lost the slide. There we go. This summarizes the end of a 12-month pilot and now the beginning of the third year of full operations using this system. After the first winter season using iPads and apps, we joked with our equipment operators about them having to go back to paper maps and colored markers, and this was their general response. And that's coming from equipment operators. They recognize that it helps them do their jobs better. It's not just something that helps the crew leaders or supervisors. And, you know, really for any system to reach its full potential, you really need to have all users benefiting from it. And I think in this case, we do. With that, I'd like to turn it back over to Matt for any questions and final comments.
Thanks, Adam. That's fantastic. I mean, it's a great solution. I think it's something we see so much benefit when folks take what would otherwise be paper-based processes and bring them into a digital GIS tool. So that's fantastic. We had a couple questions here, but I think before we get into questions, we had one more poll to run, and then we get a couple questions here. So I'll let you go ahead and do that, Marguerite.
Yeah. So if you are interested in some of the things that you've seen today, let us know. Yes, no, or yes, give us a little bit to think about it. So I'll go ahead and let this run for just a little bit here, Matt, if you maybe want to start to tackle some of those questions.
Sure. So, yeah, I guess one of the first questions we had, Adam, you know, a lot of us know it's one thing to build the technology, it's another thing to get people to use it. So how was that experience for you? How was it getting buy-in from the crews, not typically used to the process?
You know, that was probably our biggest concern. You know, with full respect to equipment operators, running technology is not really their day-to-day job. That's not really what they ever imagine they're going to be doing as part of their day-to-day work. So introducing iPads, which a lot of equipment operators had never seen or used before, that was one thing. There's the hardware side of it. And then there's the apps, the software on those iPads. And we didn't want to expose just default tools them for setting status of streets or sidewalks or whatever it was. So it was really important that we, a bit of a plug for a workflow here. It was really important that we simplified the interface for them, made it as absolutely obvious and easy for them. So it wasn't interrupting, running an iPad is not primary purpose of their job. Clearing a street or painting or sweeping is really what they're trying to do. And we didn't want the technology to get in the way of that. So we made it as easy to use. And they, our concern actually disappeared. Once they saw how this was going to help them, they just took to it. There was almost minimal or very, very little resistance to taking on these. They have to, at the beginning of their shift, sign out an iPad, carry that with them for the entire 8 or 12-hour shift, stop and update the map periodically. They have to remember not to leave it in a baking hot cab of a truck or a freezing cold outdoors. They were concerned about breakage, which we've had virtually none of. And so they quickly got over those concerns.
That's awesome. That's great to hear. I think we probably have time for one more question. Just before I do that, just want to point you folks to the apps.geocortex.com here. You can go start free trials of all our technology there, so you can check that out. I'd also just want to mention we do have a new program for our small and local government customers. So folks on the line in that space, we do have a new program around that that's pretty attractive to check out. So a couple housekeeping things there, but I guess we have time for one more question. So Adam, did you have to pre-segment the streets so the field staff could easily choose sections where work was done?
It's actually almost the opposite. The segmentation of streets and sidewalks and everything go by whatever attributes you're carrying. So it was almost too segmented. They don't, a truck's going down a road, they don't, they do the entire road. They don't stop at every intersection and then turn a different direction. They'll do the whole road. So there was overkill in our segmentation of in GIS. So we've actually created a secondary data set that has merged segments. So they can pick just one pick on the screen, selects the entire street. So we've implemented a process whereby we can automatically keep that second set of data up to date from our source data that we maintain. So it's a kind of an interesting, and we ran into it right away that the data was too segmented. It was going to be onerous for the operators. And so we've figured out a process of getting around that. And it's automatically maintained this secondary data set that's just more merged than the source data.
Cool, very cool. I think maybe we got one more minute, so maybe one more quick question here. So I think you might have mentioned it, but someone asked, what was the total time spent creating this workflow? The app, the dashboard, and the Geocortex workflow portion.
Yeah, including the business analysis that goes into this, and the documentation for the guys on the iPads and the apps and the training. I would say it was 2 months. We didn't have a lot of time. And we hope to do more piloting, but we got everything put together and then it snowed. And so we were live right off the bat. We really had very little time, but I would say it's about 2 months of a GIS technician's time to coming up from scratch. Like didn't have virtually didn't have any prior experience with workflow. So, starting from scratch, it was about 2 months for the entire effort of getting this off the ground.
That's impressive. That's fairly quick for, like you said, the BA, the testing, all that stuff, documentation. Cool. I think we're at time. There's a few other questions that we can follow up with you individually afterwards. But yeah, thank you so much, Adam and Directions Mag, for everything. This has been great, and I think it's a great solution that's applicable to beyond just streets, right? Thinking of all different assets and processes that you might be running. So yeah, thank you so much, Adam, for taking the time to share with us.
Thank you.
Thanks again to Adam and Matt for sharing their expertise. A little shout out to Brock as well for his hard work in the background. Please join us for more geospatial webinars. We hope you have a wonderful day. Tell a friend about Vertiges and Directions Magazine. Thanks, everybody.